thousands of tons of aluminum are produced every day. The United States alone consumes more than 4 billion kilograms per year. To meet this enormous demand, millions of tons of ore need to be processed. But how does a reddish rock transform into one of the most prized metals on the planet? In this video, you'll see where aluminum comes from and how it's made. It's difficult to imagine the modern world without aluminum. It's in the airplanes that cross continents, in the cars that circulate daily through cities, and in the cables that carry electricity to millions of homes. Few materials have had such a great impact on the development of humanity. One of the reasons for its success lies in its extraordinary properties. Unlike iron, which rusts and deteriorates over the years, aluminum naturally creates a thin protective layer on its surface, making it highly resistant to corrosion. Furthermore, it weighs about 3 times less than steel. This combination of lightness and strength has transformed aluminum into an indispensable material for modern industry, especially in aircraft construction, where every kilogram saved makes a difference. But the history of this metal is more surprising than it seems. Today it is common and relatively accessible, but there was a time when it was considered a true luxury item. It all began in 1807, when the British chemist Humphrey Davy first identified the existence of a new metal present in a mineral known as alum. Discovering its existence was only the first step. The real challenge was finding a way to extract it. It took almost 20 years of research before the Danish scientist Hans Christian Ørsted managed to obtain small quantities of the metal for the first time. Even then, production was extremely complex, slow, and expensive. For much of the 19th century, aluminum was so rare that its value even surpassed that of gold. To give you an idea, Emperor Napoleon III reserved aluminum cutlery for his most important guests. The others received gold cutlery, considered less exclusive at the time. But everything would change in 1886. A revolutionary discovery would forever transform the history of this metal and pave the way for the mass production we know today. Two scientists working independently, the Frenchman Paul Hérault and the American Charles Martin Hall, developed an electrochemical extraction process that is still used today. They discovered that by dissolving aluminum oxide in a salt called cryolite and applying electricity, the oxygen atoms separate, leaving only metallic aluminum. For the first time, it became possible to produce aluminum in large quantities and at a much lower cost. What was once a rare and extremely valuable metal began to be used on a large scale by industry. The importance of this discovery was so great that the Hall-Hérault process remains the basis of aluminum production to this day. But where does aluminum come from? The answer is literally beneath our feet. Aluminum is the most abundant metal in the Earth's crust, representing more than 8% of its entire composition. However, there's a curious detail: despite being so abundant, it's never found in its pure state in nature. Unlike gold or silver, there are no aluminum nuggets waiting to be collected. The metal remains bound to other chemical elements, forming minerals that need to undergo a long extraction and refining process. The main source of this metal is a reddish rock known as bauxite. It is from this rock that practically all the aluminum used in the modern world originates. The largest bauxite deposits are located in countries such as Australia, Guinea, Brazil, and Jamaica, regions that concentrate some of the largest mining operations on the planet. In Australia lies one of the most impressive mines in the sector, the Huntly Mine, considered one of the largest bauxite producers in the world. Every year, millions of tons of this ore are extracted from the ground to supply refineries and factories spread across various continents. But obtaining this raw material is far from a simple task. Before the first ton of bauxite can be extracted, miners need to remove a thick layer of rock and compacted soil that can exceed 5 meters in depth. It is at this point that giant drills, high-powered explosives, and machines capable of moving hundreds of tons in a matter of minutes come into play. What happens next is a mining operation on a colossal scale, where heavy engineering works non-stop to reveal the rock that will give rise to one of the most important metals of modern civilization. For this purpose, enough explosives are used to demolish a multi-story building. First, the rock is drilled. Then, explosives based on ammonium nitrate and fuel are inserted into the holes. Every month, hundreds of tons of ammonium nitrate are used in the operation. Daily, thousands of tons of ore containing aluminum oxide are released by the explosions. Each detonation opens new mining areas and releases enormous quantities of material for processing. Even so, each ton of ore contains only a small amount of aluminum. Therefore, approximately 4 tons of bauxite are needed to produce just 1 ton of aluminum. Mining requires billions of dollars in investment and large-scale equipment. Giant excavators and off-road trucks move hundreds of tons of ore daily. After extraction, the bauxite is transported to processing plants. It is at this point that the Bayer process begins, responsible for extracting aluminum oxide from the ore. The bauxite is crushed until it becomes a fine powder. Then, it is mixed with a caustic solution that dissolves the aluminum oxide and separates it from other impurities. The result is a concentrated solution that is subsequently transformed into crystals called alumina. It is from alumina that metallic aluminum will be produced. The alumina is transported to reduction plants, where the most important stage of the process occurs. In the factories, the alumina is introduced into large electrolytic cells filled with molten cryolite. Cryolite reduces the temperature required for aluminum production, making the process economically viable. Separating aluminum from oxygen requires enormous amounts of electricity. For this reason, aluminum is often called solid-state electricity. A significant portion of the metal's production cost is related to electricity consumption. In electrolytic cells, an electric current passes through the mixture via carbon anodes and cathodes. The aluminum oxide molecules are broken down and their atoms separated. The oxygen reacts with the carbon anodes, forming carbon dioxide. Liquid aluminum, being denser, accumulates at the bottom of the vats. After electrolysis, the molten aluminum, at approximately 950 degrees Celsius, is removed by suction systems. This process occurs continuously to ensure constant metal production. The liquid aluminum is then transferred to special containers that maintain its temperature during transport. In the refining furnaces, it undergoes additional purification processes to remove remaining impurities. After that, the metal is poured into molds to form ingots. The ingots undergo a controlled cooling process to ensure quality and structural strength. When ready, they are sent to various industries around the world. It is there that they will be transformed into airplanes, automobiles, metal structures, electrical cables, and countless other products present in our daily lives. And so ends the incredible journey of aluminum, from a simple reddish rock to one of the most important metals of modern civilization.